Hi, this is Jim Bergman for Imperial Tools. If you thought the iManifold was a game changer, well, the game has changed again. With the introduction of the wireless probes, now we can do things faster than ever. So I'm going to walk you through how quickly we can do a service test on a residential air conditioning system. I think you're going to be blown away at how quickly things get done and how much data we get back into the iManifold with how little effort. One of the comments I wanted to address was that our probes are sometimes hard to manage simply because the wires are long. Well, one of the things that I do on mine to make it super simple is I Velcro my wire right to my hose. And doing that allows me to take off the hose and have the connection right next to the line that I want to tie it to. So when I hook up my suction line, I'm going to hook up my suction line temperature and I'll have it all done in one easy step. Alright, so let's go ahead, we'll get the panels removed on the unit and I'll show you how we'll get things started. So we're going to go ahead and hook up the suction line and liquid line. I wanted to go through the whole process this time just so you can get an idea how much time things take. And you can see here, right now I have my probe right where I need it. Strap it around and it's on. Same thing with the high side fitting. Clamp this onto the discharge line. Turn the iManifold on. We have everything connected. Alright, so now that we have the outdoor iManifold hooked up, all we got to do is put one probe in the supply and one probe in the return. The probes could go inside the ductwork. They are wireless, so you don't have to have a hole drilled in the duct necessarily. I had holes drilled in here already, so it makes it pretty easy to install. All we have to do is power these on. They've already been synced to the iManifold, so there's no need to sync them again. Once they're synced up once, they're good to go. And these are magnetic again, so that literally all you have to do is put them up in the ductwork and we're good to go. Okay, so we got the probes in the return and supply, the iManifold turned on. Let's go ahead and start up the app and I'll show you exactly what this takes to get connected. So the application is up. We're going to go ahead and touch the gear button, connect to iManifold. Just takes a second for it to find the iManifold and connect. We can select the sampling rate of high, medium, or low. I'm going to go ahead and leave it on the medium sample rate. And right now, if we slide back, we can see our probes across the bottom coming in. And if we slide over, there's our return air wet bulb and dry bulb measurements. Slide again, there's performance. Nothing's happening there yet because it hasn't been running. Probe 1, wireless. Probe 2, wireless. And then back to our temperatures that are wired in there. If I open up the gear menu again, I can go to our wireless probe menu. I can see my two wireless probes are communicating because they're green. Every time they're sending signal, that'll turn green. If they turn yellow for a second, it just means it's not picking up a signal at that time. If it turns red, that means that it has lost a signal completely. We can open these up and take a look at them. So you can see it's 75 degree return air dry bulb, 63% relative humidity, and my supply is 71 and 67. So let's go back. We'll go to iManifold here, and we're going to go ahead and start the system up and start getting some readings. Alright, we are started up now, and you're going to start seeing some of the readings come in. So while this thing is running, I'm going to go ahead and profile the system. And this is a 13 to 16 SEER 410A TXV system. So I'm going to go ahead and select that. And that's going to put some indicators up on there showing where my pressures and my temperatures should be. And now that we're started here, I want you to notice a couple things here. We've added some really cool features in that'll really help you diagnose some problems here. The airflow indicator, AF, that I'm looking at right here, shows you that if you have enough airflow to properly charge the system. This is working off of our temperature split. So it's looking at temperature split of the system, and if it's in the blue, that means the airflow is too low and that we need to adjust the airflow before we continue to charge. If it is in the yellow, that means the airflow is too high. We have enough airflow to charge, and we should continue charging and see if that gets back into spec, because that again is split, and if it's in the green, we're good to go, and we can continue the charging process. So that's just based off of our temperature split, which I'm going to slide over here, which right now our temperature split is 17.3 degrees. Now you can see that we're operating. Things are starting to fall into place here. We're going to let that run for a few minutes, and you can see we don't have any subcooling on the system here right now, so we may have to address that in just a minute. But let's go ahead and input the only information now that we have to into our user inputs. Some huge changes in the user inputs now. If you look now, I'm going to open a bunch of these up here. Anything that's coming in real time, suction pressure, the high pressure, the suction line temperatures, discharge, outdoor air, none of those are editable fields, because all that information is streaming in real time. So we can leave these shut. There's nothing that we need to adjust there. If we go into the airflow and tonnage, I'm going to show you a really neat feature here. We're just going to put in the tonnage. This is a 3-ton unit, so I'm going to put 36 in here. Oops, sorry, just 3. It's 36,000 BTUs, 3 tons nominal. Hit submit. When I hit submit here, now we're going to start calculating performance. Now I want you to notice something. We're calculating BTUs in real time now without inputting airflow. And that's because if we go up here now into our system performance, the airflow is being calculated in real time. So what we're looking at here, I'm going to zoom in just a little bit so you can see this. And it's still probably got to settle out a little bit here, but we're moving an estimated airflow of 360 standard CFM per ton, 387 actual, 1080 standard CFM a ton total airflow, and 1160 actual. The difference between actual airflow and standard CFM is a standard CFM means a CFM of air that is at 68 degrees Fahrenheit, 0% relative humidity at sea level. It's that density of air. It's 0.075 pounds per cubic foot. On air conditioning, we're supposed to have a nominal 400 CFM per ton. So that nominal 400 CFM per ton is our target airflow for cooling. And you can see that it's an estimated airflow. It's calculating it off the coil performance and off the supply air, wet bulb and dry bulb, and return air, wet bulb and dry bulb. And you can see that again, there's no user input here, that's blank. So we're actually calculating the airflow in real time. So this is a very, very handy feature, because we're also calculating our tonnage, our nominal tons, our BTU sensible and latent, bypass factor, everything off the 2 wireless probes. So literally in seconds, we're up and running and doing all the calculations for the air conditioning performance. What that leaves us with now is simply one thing to put in, which I'll go back to user inputs. Which is going to be our electrical, and that is it, and we'll have BTUs and EER. So we're going to let the system settle out for a minute. We literally just started it, and I'll go ahead and start making some electrical measurements, and we'll get those input and see how the system's operating. Okay, we've got the unit running, everything's settled out now, system's profiled, and I just want to walk you through what we're looking at here and how this is going to work, because we're going to get ready to put in our electrical measurements. You need to let the system settle out and things get where they're supposed to be before you make your electrical measurements, because otherwise it's in a transitional phase. So you can see right now our suction pressure is right on, our head pressure is right on, subcooling is right in the center where it should be. We have plenty of airflow. It's right in the middle here, which means we're within 3 degrees of our split temperature. Our discharge line temperature is running about 142 degrees, and our superheat is running 10.5 degrees. Everything is right where it should be. So we're going to go ahead and get electrical measurements, and we'll finalize this thing and get it done. Alright, so now we just got to get some electrical measurements. You take just each phase to ground. So I'm going to go ahead and get the first one. We're at 120.3. Second phase, 121.4. We'll go ahead and get some amps here. 10.12, and 9.97. So we'll go ahead and put those into the app, and we'll have EER. Okay, so let's go ahead and put our electrical measurements. This is already configured as a split system, single phase, 240 volt. So those measurements were 120.3, 121.4, current on L1 was 10.12, current on L2 was 9.97. Oops. 9.97, and we'll go ahead and get our indoor, not Q, 121.4, and our current at 6.8 amps, and we'll go ahead and hit submit. Alright, so now if we scroll through here, we can see our EER is 12.25. We're running 37,800 BTUs, 3.16 tons of cooling, a 16.4 degree split. Split is dead center, where it should be, in the center for airflow. So let's go ahead and we're going to go to system performance for a second. You can see that my estimated airflow is 1221, standard CFM 1303, actual CFM. We're at our temperature split at 16.6. Our target is 16.9, so we're 3/10 away on our split. Our calculated tonnage is 3.15, our nominal is 3. We're at 37,715 BTUs total, 21,000 sensible, 16,000 latent, a sensible heat ratio of 0.56, bypass factor of 0.35. You can see our change in enthalpy is 7.30, and you can see obviously our condenser watts and our EER run about 12.20. So literally in seconds, and the time that it took for the system to settle out, and the time it took to get our electrical measurements, we have total system performance now with the iManifold and 2 wireless probes. This pretty much eliminates the need to make an actual airflow measurement unless it's a requirement for your job. We have tried this over and over again, and one of the challenges, and let me go back to user inputs for just a second. And you can enter a measured airflow. If you have an actual airflow, it will calculate based off the measured airflow in lieu of the estimated airflow. But here's the challenge. We've looked over and over and over again at trying to measure airflow, and it is such a tricky thing to do to get it accurate. The estimated airflow works off of the performance of the coil, and it is much easier to measure temperatures and humidities accurately than it is to measure the airflow in a lot of duct systems. Traveling across the country, I've had my lunch handed to me more than once trying to measure airflow simply because the system was not conducive to it, especially when we got into flex duct systems and other systems that just simply you could not measure airflow easily. So this is by far the fastest, easiest way. It's corrected. Let's go ahead, we'll take a look at my thermostat inside, we'll see what my thermostat airflow estimates and look at it compared to what we have the iManifold calculating. Okay, so you can see now we're in second stage cooling. I'm moving 1188 CFM as far as my ECM is concerned, and my temperature split here, I'm going to scroll up here, we have a 17 degree drop across the evaporator coil, and again 1188 CFM. So we'll take a look at that compared to what the iManifold's calculating and see how we did. Alright, so we're back out here, and we're at 1188 CFM on the ECM. ECMs measure standard airflow, so let's go ahead and we'll calculate that out. We had 1188 and we have 1207 when we're coming out here, so we'll take the 1207 divided by 1188 equals 1.01. 1.01, so that means we're calculating 101% of our airflow reading with the iManifold and 2 wireless probes. So we are within 1% of what our ECM says we're doing. That is pretty darn spot on here. For those of you that don't like math, there we go. So 101% of our airflow, and that is pretty darn close if you ask me. So again, you can see how quickly we can do this now because I'm not inside taking 10 minutes, 15 minutes to do a duct traverse and calculate airflow. Simply wireless probe in the supply, wireless probe in the return, power up the iManifold, and we are good to go. Alright, so now that we have everything settled out here, you can see that we are doing 3 tons of cooling and 36,514 BTUs at a 16-degree temperature split, which is exactly what the split should be as it was calculated, at 11.81 EER. Hopefully in the couple minutes that it took to shoot this video and to get the system stabilized, you can see how much the iManifold is going to be a game changer for our industry. Being able to calculate airflow with the wireless probes or estimate airflow with the wireless probes will make things so much faster and more efficient for technicians across the country. Airflow has been the challenge since day one, so now we can just simply put the wireless probes in supply and return and have all the calculations right at our fingertips. The really cool thing with the iManifold is troubleshooting, trending, data logging, all the features that are going to be coming or in the product already that'll make your job easier, faster, and simply more enjoyable. This is Jim Bergman for Imperial Tool. Thanks a lot for watching.